welcome to our tutorial on making HTTP requests. In the world of modern programming, your Python script often needs to talk to the rest of the internet. By making HTTP requests, you are essentially sending a message to a web server to either fetch data like weather updates or stock prices, or to send information from your application out to the web. Think of an HTTP request as a digital conversation. It is how your application, the client, asks a remote server for resources. Whether it is grabbing a web page or pulling data from a database, it all happens through this request-response cycle. It is the fundamental backbone of how almost every app interacts with the internet today. To make this intuitive, think of an HTTP request like ordering food at a restaurant. You are the customer or client and you send an order, your request, to the kitchen, which acts as the server. The kitchen prepares your meal based on your instructions and brings back a response, the food. If you ask for something that doesn't exist, the kitchen lets you know. When your Python code initiates a request, it travels through the network to the server. The server receives this signal, processes the logic, and packages the data back into an HTTP response. This response contains both the actual content you wanted, such as JSON text or an image, and a status code that tells you if everything went according to plan. While Python has built-in ways to handle network connections, we use the requests library because it makes the process incredibly simple. It abstracts away the complex, messy details of network protocols and gives us clean, intuitive functions. It is the standard tool for beginners and pros alike, allowing you to focus on your code rather than network plumbing. To start making web requests, we need an external tool. Python includes a standard library, but the community favorite requests package makes the process much cleaner. Open your terminal or your VS Code integrated terminal and run the command pip install requests. This downloads the package so we can use it in our projects. Once you have installed the package, you need to make it available inside your Python file. At the very top of your script, simply add import requests. This single line gives your code access to all the powerful functions that allow us to talk to web servers effortlessly. Now, let's perform our first action. We use requests.get to send a request to a website. We store the result in a variable named response. The status_code property tells us if it worked. A code of 200 means success, while other numbers indicate errors, like 404 for not found. It is crucial to understand what these status codes mean. You will see 200 constantly, which is the green light for success. You might see 404 if you make a typo in the URL, indicating the server couldn't find the resource. Finally, a 500 error means the website itself is having trouble, not your code. After confirming a successful response, we need to extract the actual data. Most APIs send information in JSON format. By calling response.json, Python automatically converts that JSON data into a dictionary we can easily work with. We then simply access specific keys from that dictionary to pull out the exact information we need. Sometimes you need to send extra information to an API, like searching for a specific term. Instead of building the URL string yourself, use the params argument. You pass in a Python dictionary containing your key value pairs, and the requests library will automatically format them into the correct query string for you. It keeps your code clean and URL safe. Servers often check who is making the request. You can pass a headers dictionary to your request, allowing you to include information like your user agent or authentication tokens. By setting these headers, you can mimic a real web browser, which is often required to successfully fetch data from professional APIs without being blocked. Tip: always use response.raise_for_status. This method checks if your request resulted in an HTTP error, like a 404 or 500 error. If one occurred, it automatically raises an exception. This is a best practice to ensure your code doesn't proceed with empty or corrupted data after a failed connection. While GET requests retrieve data, POST requests send data to the server. You use requests.post for this. By providing the JSON argument, the library automatically serializes your Python dictionary into a JSON string and sets the correct content type header for the server. It's the standard way to submit forms or create new records via an API. Never let your program wait forever for a response. Always include a timeout argument in your request, measured in seconds. If the server doesn't respond within that time, a timeout exception is raised. Wrapping this in a try except block allows your script to handle network delays gracefully rather than freezing or crashing. One of the most common mistakes beginners make is assuming every request succeeds. Always use response.raise_for_status immediately after your request. This method checks if the status code indicates an error, like a 400 or 500 level code, and raises an exception automatically. It is a clean way to ensure your program doesn't continue with broken data. While GET is for retrieving information, POST is used to send new data to a server. You use requests.post and pass your data through the JSON parameter. Python automatically handles the conversion to a JSON string and sets the correct content type header for you. The server will typically return a 201 status code to confirm the resource was created. When sending JSON data, the requests library is incredibly helpful. You simply provide a standard Python dictionary to the JSON argument. The library takes care of the complex serialization process behind the scenes. It also ensures the content type header is set to application JSON, so the receiving server knows exactly how to interpret the incoming data package. Never leave a request hanging indefinitely. If a server is slow or unresponsive, your script might freeze while waiting. By adding a timeout parameter, measured in seconds, you tell Python how long to wait before giving up. It is best practice to wrap these requests in a try except block to catch the timeout exception gracefully and alert the user. Network operations are unpredictable. To make your code robust, wrap your network calls in a try except block. You should specifically catch requests.exceptions.requestException. This acts as a base class for all request-related errors. Instead of crashing, your script can now log the error, inform the user, or even attempt a retry, keeping your application stable in real-world conditions. Time for a quick check.